Good morning to friends joining in from India, and good afternoon to my colleagues from Australia, to everyone joining us today. My name is Mohan Yellishetty, and I'm a professor in resources engineering at Monash University. And I am the founder of Critical Minerals Consortium and also Australia-India Critical Minerals Research Hub. So first of all, a hearty welcome to the workshop on advanced manufacturing technologies, part of Australia-India Research Collaboration Framework, where we will explore opportunities for collaboration in the field, a very, very important area of greatest significance to both our nations. And I am joining you today from India. But before we begin, I would like to formally acknowledge the traditional custodians of the lands on which our Australian colleagues are joining in us from today. Today's workshop is hosted by Australia-India Institute, which is based at the University of Melbourne, as my university, Monash, on the lands of the Wurundjeri people of Kulin Nation, and I pay my respects to their elders, past, present, and emerging. So I would also like to acknowledge the presence of two very distinguished guests among us today. The Honorable Lisa Singh, the CEO of Australia-India Institute, and we also have Ms. Kali Partridge, who is Acting Deputy High Commissioner of Australia to India. So welcome, both of you. So the program is jam-packed, so I will straight away get into calling on the Honorable Lisa Singh to kick off with her opening remarks. Over to you, Lisa.
Thank you so much, Mohan, and I'm really delighted to welcome everyone to today's workshop on advanced manufacturing technologies, and join with Mohan in wanting to acknowledge the traditional owners of the land on which we meet with you today. Can I also welcome all of you for joining, but particularly to Ms. Kali Partridge, the Acting Deputy High Commissioner to India in Delhi, and also very much to the co-leads themselves who have really helped bring today together, which is, of course, is you, Professor Mohan Yellishetty, and also Mr. Rajat Verma. Your expertise and leadership are really important in guiding today's discussions. This is one of 4 workshops for the Institute. It's informing the development of the Australia-India Research Collaboration Framework, or AIRCF, as we call it sometimes. The other themes we're exploring as part of the 4 workshops are energy transitions and climate change resilience. And we had an excellent workshop most recently on that, as well as sustaining healthy communities and cybersecurity and digital governance. All very much topics that are very much important in terms of driving research collaboration between our 2 countries, but also for the times and the region that we live in. I think at the core of this framework is really, though, about providing a practical, adaptable resource to strengthening research collaboration between our 2 countries. It's building on the digital platform of AIRC India, which is hosted by the Institute, which connects researchers from Australia and India together. And this framework goes further than that by offering really targeted guidance for long-term partnership development. The project itself is supported by the Australian Government through the Department of Education, and I would like to acknowledge the department and thank them for making this work possible as well. I think in terms of today's topic, advanced manufacturing is really central to our shared goals of innovation, of a cleaner energy future, reaching net zero targets, finding new, secure supply chains on various issues. There is just so much scope when we think about advanced manufacturing for a modern economy of Australia and India that we're both moving towards. So that is really our focus for today. I'm very much delighted to see so many experts from academia, from industry, and also from government here today, because your contributions very much will drive and inform this framework and help shape the sort of future that the Australia-India cooperation, research cooperation in this field can develop and work out what it can become in terms of industry development, further research development. The scope really is up to us to really see how far we can drive outcomes in this advanced manufacturing space. So with that, I very much just want to wish you a very engaging and productive discussion, to really be open and share those sorts of ideas and expertise that you have that can really help inform this important Australia-India research collaboration framework. And I look forward to hearing all about the insights that you share and that will emerge from today's strategic dialogue. So thank you. Thanks, Mohan.
Thank you, Lisa, for keeping it so brief and very, very sharp. Thank you. I now have the pleasure of inviting Ambassador Kali Partridge, the Acting Deputy High Commissioner of Australia to India. So, yeah, over to you, Kali.
Thank you so much. Hello from Delhi. Really lovely to see all of your faces. Of course, I'd also like to acknowledge the Honourable Lisa Singh, Dr. Yellishetty and Mr. Rajat Verma today. I wanted to start by saying that from our point of view in the Australian government, the Australia-India relationship is at its highest point ever in its trajectory. So we often talk about this as having three components or three compartments, if you like. One, there's a huge amount of what we always talk about as strategic convergence. We have a really shared vision for our Indo-Pacific region. Two, there's huge economic complementarity in our relationship, and the way that our economies fit together, the jigsaw pieces of those economies, is very complementary rather than competitive. And thirdly, we always really like to talk about the human bridge, the fact that there's a huge number of Indian Australians, and this is a really important part of Australia's identity and culture, and undergirds the entire Australia-India relationship in such an important way. I wanted to talk about a few things. I'll be brief, but one thing is to say that our Prime Ministers have met 6 times in the last 12 months. That's, for 2 very busy Prime Ministers, quite impressive, and that doesn't even begin to capture the ministerial level engagement. So I think that just sets a bar for us in terms of the closeness and the passion and commitment to the relationship. Of course, the Australian Prime Minister released a new roadmap for Australia's economic engagement with India earlier this year, and 4 superhighways of growth were part of that, where our countries have natural strengths and those jigsaw pieces I talked about. So we're really pleased that today they'll be focused on 2: clean energy, education and skills. So our economies, India has scale, speed and drive. Australia has tech, minerals and skills. And, India also has this incredible workforce, this incredible diverse and deep pool of talent. So to dig down a little bit, Australia has the critical minerals that help to realise India's electric vehicle manufacturing ambitions. Our economic cooperation trade agreement, our interim trade agreement, is saving hundreds of millions of dollars in tariffs for businesses. And we're working now on upgrading that to a comprehensive economic cooperation agreement, really working very hard. We've got a negotiating round next week, and that's going to dramatically ramp up critical minerals trade and help power India's renewables manufacturing. People are the lifeblood of the relationship, which is why research collaboration is so vital, and skills development through initiatives such as this one. So I too extend my warm appreciation for you all today, for the discussions that you're going to have. And I too, like Lisa, am really excited to hear what you produce. Some of our best minds working together on shared problems. It's really gratifying to us in government. So thank you immensely. Back to you, Dr. Yellishetty.
Again, once again, thank you, Kali, for that, again, very sharp and very, very sharp message. So now we move on to the next phase of our workshop. So over to Rajat.
Thank you, Mohan. Let me begin by acknowledging Honorable Lisa Singh and Ms. Partridge's opening remarks. Thank you very much. We will begin today's session with an overview of the AIRC framework, followed by a series of expert presentations offering Indian and Australian perspective. After that, we'll move into three themed sessions, breakout sessions, where we'll invite your participation. Before we get started, let me quickly introduce Professor Yellishetty and myself as the co-leads for this session. Professor Yellishetty obviously is a professor in the Resources Engineering Department in Monash University, but he's a leading expert in sustainable mineral resources. Professor Yellishetty has been associated with several esteemed institutions such as CSIRO, Yale University, and IIT Mumbai. Amongst various other things, he has founded the Australia-India Critical Minerals Research Hub and the Critical Minerals Consortium at Monash University. As far as I'm concerned, my name is Rajat Verma, and I'm the founder and CEO of LOHUM. At LOHUM, we work at the intersection of critical minerals and sustainability. Amongst other things, we are the largest recyclers of critical mineral-bearing waste in India, and also the largest producers of various critical minerals such as lithium, cobalt, and nickel. We are also about to commission our processing facilities for rare earth elements as well as the platinum group metals. This is what we've been doing ever since over the last decade or so in our journey. Professor Yellishetty and I met maybe a year to a couple of years back, and given our common interest in sustainability and critical minerals, we decided to join hands and see in what ways can we further the Australia-India partnership, both at research level as well as at the industry level. And one of the things that I really want to see if we can bring out of this particular discussion is a closer relationship between academia and industry. How do we actually take academic research and bring it to the industry, make commercial projects, make commercially viable projects, and thus solve the critical mineral needs of both our respective nations. With that, having said that, I would now like to introduce Associate Professor Haripriya Rangan, Principal Consultant of Government Projects at the Australia-India Institute. Priya will take us through the Australia-India Research Collaboration Framework, which underpins today's thematic workshop. Thank you.
Thank you, Rajatji, and good morning, good afternoon to all of you. I intend to keep my presentation very short and just give you an idea of how we are sort of conceptualizing this framework. As perhaps you may know that over the past 20 years, the research collaborations between Australia and India have grown significantly, and now we're at that critical point where we want to take it further and come up with a framework. So here's how we're sort of conceptualizing or asking you to think about our relationship in research and how we might make more of it and go further and deeper through this archway that we've conceptualized. Broadly speaking, what the researchers are actually supported by a whole bunch of stakeholders and initiatives, which is undergirded by this foundation of the different kinds of relationships that our two countries have. And each of these stakeholders, whether it's the ministers or the different funding schemes and industry and government sectors, the higher education institutions and their specialist centers. They're all involved in some way or the other to support the researchers working in both the countries. But what's important is that in your areas, in the kind of collaborative activities depends a lot on the kind of work that people are doing in some of the emerging and critical areas like we're going to talk about today. And each of these kinds of areas requires certain things which are not uniformly, they're not the same across all the different sectors. So the arch that we have kind of sketched out, the space for collaborative activities, is what we would like you to think about when you're having your discussions, and think about which of these stakeholders, what kinds of initiatives would be required to promote the kind of collaborative activities you are looking forward to pursuing. How can you bring a new generation of researchers, early career researchers, women researchers, people from diverse industry and government backgrounds into a long-term relationship, how to provide a whole range of outputs and impacts. So I would like to basically say that we'd like you to think of all of these players and the kinds of initiatives and activities they can promote, they can come up with to promote research partnerships, how they can sustain and strengthen the collaborations between academia and government and industry over the longer term. How can they translate the work that's being done, that is emerging, to come address some of the big challenges and innovation and production systems and improve productivity in both countries. So I really look forward to your discussions and inputs on helping us come up with this exciting framework that will sort of forge the ground for a new generation of people to work and build closer ties in our research relationship. Thank you so much. Over to you, Rajat.
Thank you, Priya. Thank you for your remarks. We'll now hear from a group of distinguished speakers who bring deep expertise in critical minerals, sustainability, renewable energy, and resilient supply chains, all essential to the future of advanced manufacturing. Their insights will help frame today's discussions, offering both Indian and Australian perspectives on key opportunities for collaboration. Given the jam-packed schedule that we have, may I request the speakers to limit their presentation to 8 to 10 minutes so that we can cover all the interesting things that we want to cover in this workshop on time. Our first speaker is Shri Anshu Pandey, Director of the National Critical Mineral Missions in India in the Ministry of Mines, Government of India. He leads efforts to secure key minerals for India's clean energy goals, such as electric vehicles, battery, and storage, solar technologies, and to obviously certainly reduce India's import dependence through domestic exploration and processing. I've had the pleasure of interacting with Shri Pandey now over the last couple of years as he's led the efforts in the Critical Mineral Mission, and he brings amazing perspectives to the table. Let's hear from him now.
Thank you so much, Rajat. Thank you, Professor Mohan, and good morning to everyone present here. I hope I'm clearly audible to everyone. Okay, thank you. So it's really a privilege and honor to be here for this important workshop on advanced manufacturing technologies. And I'll be mindful of time. I'm starting at 10:18, and before 10:28, considering the paucity of time, I should surely wind up. And I'll be sharing India's policy perspectives on critical minerals, and also how both of our countries can join hands together, can collaborate in different ways. So let me start with where India stands today as of now in field of critical minerals. We are over $4 trillion US dollar economy, the fifth largest in the world, and also the fastest growing economy in the world. And this growth is driven by technology. Our industries are moving towards electric mobility, renewable energy, advanced electronics, modern defense systems, and other high-tech sectors. So for all of this to happen, critical minerals are the basic foundation. We know Rajat is expert. Lithium is required for batteries, cobalt and nickel for EVs, rare earth for wind turbines and electronics, graphite for energy storage. So without them, it's difficult to imagine the world and it's difficult to imagine the clean energy transition. It cannot happen without the critical minerals. So considering these factors, our country, India, has set up some very ambitious targets of 45% reduction in the emission intensity from 2005 levels, 30% capturing EV market share by 2030, and a net zero emission by 2070. This means that millions of electric cars and thousands of renewable energy installations, and there will be massive demand for battery and energy storage, all requiring a secure supply of critical minerals. And that is precisely why our partnership with countries like Australia is so very important. Australia has had a long and successful mining tradition, a strong regulatory system, and some of the best ESG practices in the world. It is the world's largest producer of lithium and ranks among the top 5 producers of cobalt, manganese, rare earth, rutile, and tantalum. I've had the privilege of visiting Australia last year, where I first met Professor Mohan Yellishetty at IMARC. And I must appreciate the approach that Australia is adopting for its critical minerals, where the federal government offers grants, tax incentives, subsidies, and financing facilities to support production and processing. And the state governments add on to it their own strategies based upon the local conditions. That's how they customize it. Their focus is on public-private partnerships, skill development, sustainability, and recycling. So India is also building its own model considering our unique needs. And I'm happy to share that in January 2025, the government of India launched the National Critical Mineral Mission, which of course I'm looking after. I'm the director of the National Critical Mineral Mission. And the duration of the mission is up to 2030-31. And the aim is to secure supply and build a complete value chain from exploration to mining to processing, and it includes recycling as well. So for this mission, our government has allocated rupees 16,300 crores, which translates to about $2 billion US dollars. And we expect an additional investment of 18,000 crores, which is somewhere more than $2 billion from public sector undertakings and our private players. Our mission focuses on increasing domestic production, acquiring mineral assets abroad, recycling minerals from the end-of-life products, expanding trade and markets, research and technology development, training skilled manpower, strong funding and fiscal incentives. And we have already made significant progress in this critical mineral mission. So in August 2023, in India, this mineral licenses are given through a process of auction. So considering the importance of critical minerals, in August 2023, the power to auction these critical minerals was taken over by the central government. That is, the central government does the auctions of these critical minerals. And so far, the Indian government has successfully auctioned 34 blocks of critical minerals. The Geological Survey of India has been taken up the projects of critical minerals, the exploration of critical minerals on priority. Last year, we had taken up 195 projects, and this year, we have taken up 230 projects of critical minerals. We have a trust known as NMET, National Mineral Exploration Trust, which funds both public and private exploration in India. We are also bringing some landmark changes in our Minerals and Metal Development Regulation Act, which is known as MMDR Act. So this amendment will allow National Mineral Exploration Trust funds to be used for exploration outside India, which will be a big step to secure overseas mineral assets. And it also proposes a lower revenue share for associated critical minerals discovered during mining. So this is aimed at encouraging investment and faster development. So you would have read in the news that day before yesterday, this bill was passed in Lok Sabha, and it is expected to be passed by our parliament in this session itself. So it is a very significant bill, and it is going to bring some radical changes in our mining sector. We have also cut import duties on cobalt powder, lithium battery scrap, lead, zinc, and 12 more critical minerals. And I'm also happy to share in this forum that of late, very recently, only 15 days back, the government of India has recognized 7 centers of excellence for critical minerals, which includes 4 IITs and 3 R&D labs. So we are very sincere, we are working keenly on advancing research in the field of critical minerals. We have launched pilot projects worth rupees 100 crores, which is about 12 million US dollars for mineral recovery, and a major rupees 1,500 crore schemes, which is about 180 million US dollars incentive scheme, is likely to be announced very soon. Very soon means within a month, which is exclusively meant, excuse me, which is exclusively meant for recycling and to promote recycling, and it is expected to be launched shortly. So now this was the policy framework. In next 2 to 3 minutes, I'll introduce where we, India and Australia, stand today. Internationally, India and Australia work very closely. We are partners in Mineral Security Partnership. We are partners in Indo-Pacific Economic Framework. We are partners in the Quad Framework. We also have different bilateral collaborations among our two countries. Our joint venture company called Kabil Kharij Videsh India Limited has signed an MOU with the CMFO for investment in Australian lithium and cobalt projects in 2022, which has made significant progress so far. And Geological Survey of India and Science Australia have also signed an MOU for joint exploration and research. There has also been progress on this front. There's an Indian-Australia Mineral Scholar Program involving postdoctoral exchange, joint symposiums and research mobility through CSIR in 2023. And of course, I must highlight the role of academia in this partnership. I must mention the name of Professor Mohan from Monash University, who is actively working with the IIT Hyderabad on joint research projects in critical mineral processing. These collaborations are certainly helping us to develop the technologies that will define the next generation of clean energy systems. We also have a comprehensive economic cooperation agreement with a dedicated chapter on critical minerals. So India certainly brings some unique strength to this partnership. We have a young population of over 40% under the age of 25. We have a strong network of research institutions and world-class engineering talent. Australia brings rich mineral resources, advanced mining technologies, and R&D capacity through organizations like CSIRO. And we need to combine these strengths of India's talent and manufacturing capability and Australia's resources and research excellence. We can create resilient, transparent, and sustainable supply chain that benefit not just our two countries, but the entire world. To make this happen, we must focus on joint technology development, especially for processing, beneficiation, and recycling. We must focus on efficient use of raw materials so that we get more value from every ton that we mine. And we must focus on large-scale recycling to reduce mining pressure and protect the environment. So critical minerals are present everywhere. Their importance is visible everywhere, in every battery, in every wind turbine. The choices that we make today on where we source them, how we process them, and how we recycle them will shape the world for decades to come. India and Australia have a chance to lead this change together, and I believe we definitely shall be doing it. Thank you so much for this opportunity, and I'm finishing exactly in 10 minutes. Thank you.
Thank you, Pandeyji, and thank you for finishing exactly at 10:28. I think that sets the bar high for the rest of the speakers to ensure they finish their presentation on time. Our next speaker in series here is Farhan Ahmed, Chief Financial Officer of Intel Corporation's Client Computing Group, which is amongst the most profitable businesses of Intel Corporation. Mr. Ahmed brings over 25 years of leadership experience across the semiconductor technology and clean energy sectors, and is amongst the rare set of folks in the industry who actually started his career as a technocrat before taking on leadership roles across the semiconductor industry. Farhan, over to you.
Thanks, Rajat. So I'm going to change gears a little bit from the critical minerals and just talk at a very high level about the opportunities in the semiconductor value chain for Australia and India. So I'll start with just a very high-level overview of the semiconductor industry. Maybe if you can go to the next slide, please. So if you look at the semiconductor industry, it's really an exciting time to be here. I've been in the industry for 25 years across various different companies, and this is probably the most exciting time. If you look at the growth rates in the industry, the growth is actually accelerating in a very big way. And in my first 15 years, from 2000 to 2015, the total growth was about 50% over 15 years, so about 3% a year. And more recently, the growth has just accelerated. Last 5 years, the industry has grown about 60%. And from 2015 to 2030, the growth is expected to be about 200% over that period. So really tripling over 15 years. So that's really exciting time. Now, what's interesting about semiconductor industry is that it is a very high value industry. If you look at the profitability in the industry, it's somewhere in the range of 60% gross margins, about on an average. And that's money that's invested in R&D mostly. And that leads to a lot of advanced technologies and very specialized functions across the industry. And if you look at the semiconductor industry, almost every company is a monopoly at what they do, and or like one of the two players in that segment of the market. So it's very specialized. And this is an industry, and no matter what you do, R&D is extremely critical. So maybe if you can go to the next slide, I'll just talk at a very high level about the different parts of the value chain. Now, if you look at the semiconductor industry, the main parts are basically the manufacturing. And within that, there is a chip manufacturing and then packaging and test. The chip manufacturing portion of it is very capital intensive, very advanced technology. The packaging and test is somewhat less advanced. And then there are suppliers to both these portions of the manufacturing industry. There are equipment suppliers, and then there are material suppliers. And then outside of this, there's software and chip design. Now, what's interesting is that while this industry is $1 trillion industry, it's really concentrated in few advanced economies in Asia, in Europe, and US. So there are very few countries today where there is a big presence of manufacturing. If you look at India, or Australia, there's nothing that you can see there. If you look at any of these companies, there's no Indian company that's there right now. Hopefully that'll change over time, but it's very, very concentrated in few different countries. So all this growth that is happening right now, in a way, is the benefit is really going to few places. Now, if you go to the next slide, this is also a place where, when you are entering a new industry, you have to think about what are the places that you want to enter. And it's actually a good time for countries to start looking to enter this industry because of the geopolitical issues that are happening, there is an increased desire to replace, to build a supply chain where there is not that much reliance on China, and especially with Taiwan being so close to China, there is a desire to move away from that geography to other geographies. Now you look at Australia and India, they both have their strengths. In Australia, there is a lot of strong R&D, particularly like in EDA, quantum computing, and system integration. There's one company, Altium, that I'm familiar with in Australia that's at a global scale. And then the supply chain is also what's very important is rare earths, because a very vast majority of them are today coming from China, so opportunity to build there. And because it's also a secure country and advanced country with a good infrastructure, there is an opportunity to build a supply chain for the legacy chips. And because of the R&D, I would say focusing on startups. And then the last thing is building on the strengths in EDA and just expanding on that. And then when you turn to India, I think the strengths are basically you have a very strong labor supply, you have a large market with 1.4 billion people. And there's a government right now that is very supportive of the growth in semiconductor industry. So for India, the opportunity really is to incentivize the market access. China has used this very effectively and use that to incentivize the companies to come to India in a bigger way. India has already got chip design strengths, so really strengthening that further. This is an industry where countries and economies tend to specialize in what they do, and I think like for India, it's really chip design is an area where India can really shine, given how much talent is there. And then the last thing is in manufacturing, I would say really go after the places where labor is more important, like packaging and even going into system assembly, which are the customers of semiconductors, before really moving into fabs, because fabs take up a lot of money and you don't generate a lot of employment, and it's a very big risk for a country like India. So that's all I had. I also completed my presentation in 8 minutes.
Great. Thank you, Farhan. Thank you for your insights. Certainly, semiconductors is a great area for our two respective nations to collaborate, right from minerals all the way to market. And I hope we see a lot more collaboration, both at research as well as industry level, at business level here. I believe Dr. Loh is back now. I'll reintroduce Dr. Loh. Dr. Loh manages CSIRO's India-Australia Critical Minerals Research Partnership, where she leads collaboration between researchers, industry, and the government in both countries to deliver projects that strengthen and integrate critical mineral value chains. Over to you, Dr. Loh.
Thank you so much, and apologies for my technical difficulties. Good morning and good afternoon, everyone. My name is Joanne Loh, and I'm very pleased to give you an introduction and a bit of an update on India-Australia Critical Minerals Research Partnership. So we were funded through appropriation funding under 2022-23 budget measures from the federal government as part of the comprehensive strategic partnership with India. That funding is also extended to a Green Seal partnership as well. So for us, our project finishes June next year, and the objectives are really to strengthen supply chains, add value to Australian exports, and to commercialise CSIRO-owned critical minerals technology. And by doing this, we're going to contribute to diversified, resilient, responsible supply chains, new jobs and industries for both countries. In terms of the context, it's really centred around the policies related to critical minerals for both India and Australia, and the intersection of these for mutual benefit. So we have the Make in India initiative and the Future Made in Australia Act, which are both focused on developing and using and value adding to natural resources, and about capturing more of our resources onshore and have a greater participation in global supply chains. So for India, it's reducing reliance on imports, and Australia, it's really getting those resources at a higher value. There are a lot of commonalities between the critical minerals list for both countries. So this 2021 India-Australia joint report on critical minerals was actually really important to narrow it down from a list of 30 minerals. So our partnerships really focus on these 7: lithium, nickel, cobalt, rare earths, titanium, vanadium, and graphite. So we have 4 projects that are funded by the partnership, and it's all around supply chain. So just to show you where our projects sit, we have one in mineral exploration, one in mineral processing on the mining side, and then we have smelting and refining, and fabrication and design and manufacturing stages. So just a brief overview. So our first one's targeting and characterising critical minerals in India projects, really about expanding the knowledge and increasing a chance of discovery of critical minerals in India. And that's to improve domestic supply and reduce import reliance. So this diagram basically shows the project and our project partners with India. So we have 2 universities and Geological Survey of India, where it's really the project is focused on nickel, cobalt, lithium, and rare earth. So our project leader, Dr. Ramanadu, and his team actually completed 3 separate field trips in over 11-month period in India, who worked very closely with GSI, Javadpur University and IIT Mumbai in terms of sample collection throughout India. So these samples are currently undergoing CSIRO state-of-the-art analytical techniques and software tools to develop new ways to detect high-value critical minerals deposits. So during these trips, they've also given seminars and presentations as part of knowledge transfer exchange with researchers. And the bottom right photo shows Australian Consul General Mr. Boylan also visiting the collaborator Dr. Mondal in January to discuss the project. The second project is a titanium vanadium process where CSIRO has a patented process for a low temperature atmospheric leach extraction to recover titanium vanadium from mixed ore deposits. So conventional processes can only recover one. So this process offers the opportunity for multiple revenue streams. So the project so far has been very successful in recovering high value products, high purity. So with this particular project, there's been a lot of engagements, and I'd like to highlight a couple of those. So we worked with Taiwan, an Australian company, to optimise the process for the world's largest vanadium deposit and produce a very pure vanadium product. We've also commenced a collaboration project with CSIR IMMT earlier this year, in which they will further refine the process with Indian ores. We're currently in the process of signing a collaborative research agreement with CSIR NML to value add to the byproducts that come from the project, from the process. And we're currently working Monash and IREL in terms of the supply of Indian titanium and VTM ores. Our third project is around novel processing for rare earth metal and alloy production. So it's really focused around the development of beneficiation, separation, metallization processes for rare earths. And it's hopefully to eliminate or even shorten processing steps of conventional techniques to more easily separate and recover pure metals. There's also potential for pure metals or alloys and or even metal powder production. So the project has had some recent success in the high temperature beneficiation of tailings to increase rare earth concentrations from at 8% up to 20% in the slag. We've also been able to produce lanthanum, neodymium and diasporium metal powders and sponge as well at 50-gram scale. And our last project is focused on sustainable cathode production for both lithium and sodium-ion batteries. So it's really targeting key knowledge, technology, capability gaps in the battery material supply chain for both nations. So the current focus for lithium-ion cathode aspect is really around impurity levels and their effect on electrochem performance, with the sodium-ion battery looking at the synthesis of these transition metal oxides to really target higher energy densities and performance. As part of the partnership, we also fund the Scholar Network, and these are some of our projects in green, and you can really see the complementarity to the partnership projects. We funded 13 student projects, with the majority of the student projects probably in the recycling and recovery area to bolster our capabilities in this field. So this map just shows you a quick snapshot of where our students come from. As part of the Scholar Network, we've also collaborated with the Australian Critical Minerals Research and Development Hub and have put together a 2-week critical minerals study tour. So there's going to be approximately 30 attendees with 7 of our Scholar Network students attending. The other attendees will come from Australia's other partner countries, EU, UK, US, Canada, Japan, Korea. The tour itself is centred around the AusIMM Critical Minerals Conference that will be held in Perth in early September, but they'll also be going out to Kalgoorlie School of Mines and having site tours and cultural activities. Lastly, I just want to touch on the National Critical Minerals Mission that Shirapati mentioned. I just wanted to show in terms of where SARA can play a part, we're very well placed to support the mission. So establish and advance technologies and capabilities along the critical minerals value chain, collaborate with researchers, obviously via CSIRO's managed initiatives, this partnership, the Scholar Network, and the Hub, and of course leveraging CSIRO's global R&D collaboration networks. And lastly, as mentioned, there were 7 centres of excellence that were announced last week, and I'm proud to say that as part of Critical Minerals Partnership, as well as the Green Steel Partnership, we're already collaborating with 6 of those 7. Thank you.
Thank you. Thank you, Dr. Loh. As a practitioner in the industry, I would say all these projects are cutting edge, and I hope a lot of them make it to TRL 9 levels and are actually adopted widely by the industry. I'm also encouraged by the fact that the younger generation is also taking keen interest in these areas. At LOHUM as well, we hold both summer and winter camps for high school students to do hands-on projects on sustainability and critical minerals. And I just thought I'll use this opportunity to spread the word to involve more folks from the next generation to come and learn about the future of the world. What is even rarer than rare earth is an ability to finish a session on time, which is what we've been able to achieve today. So I'll now hand it back to Professor Yellishetty to lead the next part of the session.
Thank you, Rajat. I think that shows that you are not only very meticulous in standing up businesses, but also running sessions like these. So thanks everyone for your contributions. So we will now move on to our breakout discussions. I think there are some housekeeping rules that I'm going to kind of run through. In each session, a key speaker will set the scene before inviting your feedback on the topic. And then please note, group discussions are being recorded only for internal note-taking purposes, and in no way that any comment that you make or any suggestions you make will be attributed to any individuals who are making those contributions. And the first breakout session is Materials Innovation and Circular Economy for Sustainable Manufacturing. The session will focus on, anyway, I will leave that to the session head to kind of reiterate, but the main purpose is to get some deeper insights into these issues from the experts who are attending this. And one of the very reasons that AII is hosting this workshop is the insights will be captured and the discussions will help inform the promote pillar of AIRC framework, which Priya has kind of alluded to before. How we can encourage the development of new and interdisciplinary research collaborations. I will now hand it over to the breakout session lead, Dr. Sarb Gide, who is one of my good friends, and we recently held a joint workshop between CSIRO and Monash. He is a world-leading authority in energy storage and recycling. So over to you, sir. Thank you so much.
Thank you, Professor Yellishetty. So this session is going to be focusing on materials innovation and circular economy for sustainable manufacturing. The focus areas are going to be innovations in circular, in critical minerals, processing and extraction, resource-efficient technologies, and semiconductor design and manufacture. Circularity in design, waste valorization, urban mining, and design for recycling. And the third focus area is on the bilateral research opportunities in critical minerals extraction and processing, resource-efficient technology, and semiconductor design and manufacture. This session will also aim to provide insights for the promote pillar of the framework, which aims to explore key stakeholders involved in research collaboration within the theme of advanced manufacturing technologies and their role in promoting collaboration, best practices and mechanisms that initiate collaboration. And the third aspect is on what's needed to attract new researchers not yet involved in Australia-India research collaboration. So as Professor Yellishetty mentioned, the session is going to be total 25 minutes. So I would provide a bit of opening remarks that's around how this session is relevant to my work. So my group is involved in developing hydrogen-related materials and technologies such as fuel cells, electrolyzers, hydrogen separation, purifying membranes, metal hydrides for hydrogen storage, and compression, including developing battery recycling, complete suite of technologies. The R&D in this space is deeply intertwined with materials innovation and plays a critical role in advancing the circular economy for sustainable manufacturing. For example, the catalysts or electrode materials currently used in the electrolyzers and fuel cells use platinum group metals such as platinum, ruthenium, iridium, or rare earth materials like lanthanum, strontium, or materials like nickel, cobalt, vanadium. So research is exploring how the use of these materials can be either reduced by improving their performance or how these materials can be recycled from the end-of-life devices. Further, the hydrogen technology influence circularity in multiple ways. For example, by developing cell and stack design for end-of-life disassembly and recycling for modular replacement and materials recovery. That is important for closing the materials loop. Hydrogen R&D also supports sustainable manufacturing through energy efficiency by developing innovative materials for improving efficiency of hydrogen conversion technologies, reducing energy waste, and also durability and longevity by materials improvements that extend equipment life, reducing waste and materials input needs, and resource efficiency, that is reducing or substituting critical raw materials, rare earth platinum, for example, and that aligns with the resource efficient manufacturing. So this is a bit of a context around how this session is quite relevant to hydrogen related technologies. Thank you everyone for your contributions, for your insights, where you are experiencing challenges to really look at how the technologies can be moved from the lab scale to the commercial scale. So I would just like to provide some concluding remarks from the session. So we could see that there are some arrangements already in place between India and Australia in terms of funding available and some bilateral collaborations already happening. Some of the projects already happening which came from CSR presentation as well. We have lots of projects being executed, but I think probably the challenge is still how we move the technology from lab scale to commercial scale and how we can make our large industries interested in these technologies, where they can provide a lot of fund to this area. So, and how these technologies can be moved to basically make it a pilot scale and then make some companies interested in there. So lots of some ideas came out actually. For example, having more PhD programs, maybe industry PhD programs, or maybe even looking at some CRC kind of a model actually, which is quite successful here in Australia, where they are industry led basically collaborations actually. So that's where what is coming out. And Professor Yellishetty, is there anything else you would like to conclude with.
Oh, no, thank you. I think you've done a fantastic job, and I just only step in to express my sincere gratitude and thanks to you, Dr. Sabjit Gide, your extraordinary leadership in steering the discussions. And I'm sure my colleague Brian is listening in and then capturing some of the key points there. And yeah, I think
Excellent.
Fantastic. Thank you so much.
Thank you.
Everyone
Thank you for the
participating.
invitation, and thank you for involving me in this one. Thank you.
Welcome back, everyone. We now start Breakout Session 2, which is about driving climate-smart advanced manufacturing. This session will be conducted by Professor Rajesh Kumar Dubey, who is a professor of civil engineering at IIT Kharagpur. Some of you may have heard him speak earlier in the panel, earlier in the session. Dr. Dubey has over 20 years of research, teaching, and consulting experience within the broad areas of environmental, sustainable, resilient engineering and circular economy. A highly published academic, he ranks globally number 3 for his research in the area of waste management and circular economy. I'm going to remind everyone of the rules again. The session will be recorded for internal note-taking only to support development of the AIRC framework. We encourage everyone to participate and contribute in candid manner to the discussion because that's the only thing that will further our combined goals of this session. Over to you, Professor Dubey.
Thank you, Rajat, for the introduction. So I just wanted to start with a very brief presentation of around 4 or 5 slides. So I will share my screen and we'll get started with that. Okay, so I think you can see my screen. So thank you again and welcome to this second breakout session. So as the session suggests that we are looking at driving climate smart advanced manufacturing. So when we talk about climate resilient or climate smart, the one thing which does come into mind is how to have decarbonization, isn't it? How to reduce the carbon footprint. So when we think about carbon footprint, of course, we'll look into AI and IoT and other stuff because that's not my domain. My domain in terms of decarbonization, when I kind of work on, is to look at having that life cycle thinking in any manufacturing process. So when you look at any manufacturing process, how to incorporate life cycle thinking there. So that's what I will try to highlight as part of my opening remark. So in terms of when we talk about this advanced manufacturing, see, of course, it has to be, people talk about 3D printing, there is an automation, robotics, AI, ML, like artificial intelligence, machine learning is there. Then we talk about advanced material as well, then composite, nanomaterial, bio-based material, and also we talk about Industry 4.0, which is kind of a smart manufacturing system. So if you look at the key characteristics of that, they are technology driven, high precision and quality, sustainability oriented as well. And then we try to integrate the data. So data integration is there. So if you talk about this modern manufacturing, it's not only about making a product, it's actually about making something efficiently, sustainably, and competitively. Well, you're looking at the entire journey of the product, like from having a life cycle thinking from the raw material extraction all the way to end of life. And today, actually, we are not even talking about end of life. We talk about bringing that back into the economy. That's where the circularity comes in picture. So life cycle thinking. So in terms of broadly, what we are looking at in terms of core principle, holistic perspective, don't do a burden shifting. We should avoid burden shifting, having the 3 bottom line approach, where integrate environment, economic, and social consideration, and have data-driven analysis for sustainable choices. So starting from raw material extraction, manufacturing, assembly, distribution, transportation, use phase, end of life management, which kind of again talks about recovery of the material and bringing material back into the economy. So while we are going through, depending on the industry we are working at, so when we are looking at different types of industries, electronic industries or mining industries and all those different industries where the critical minerals and those things are in picture, we can have variety of approaches depending on our scope. Can we have a gate to gate where you're just looking at the process itself? You can have cradle to gate. We're looking at the entire from the mining all the way to product, or you can have cradle to grave or even cradle to cradle. So where you are basically looking at total circularity in picture. So that's so how it is different from traditional approach. So when we look at the all stages from raw material disposal all the way to the raw material to disposal. Traditional approaches focuses mainly on the production stage. Impact assessment is holistic rather than having limited to direct economic or technical factor. Decision making tries to take into consideration the long-term sustainability, avoiding burden shifting, while traditional approach that we have today is mostly short-term and stage-specific optimization. Data use, process stage data and impact modeling. Goal is to minimize the total impact. That's what we are trying to make it happen. So when we talk about climate resilience or climate smart, of course, carbon footprint becomes very, very important because that's one of the major factor. So look at the total greenhouse gas emissions, how you following that GHG protocol, ISO methodology, looking at the material flow analysis, including the reverse logistics when we talk about our in terms of recycling and resource recovery, looking at circularity, having come up with some sort of circularity index and taking that cost, economic, social, and environment, all three into the picture. So why there is a need for life cycle thinking, especially when you talk about climate smart advanced manufacturing, it helps us to make holistic decision making, environmental sustainability, economic efficiency. You reduce your risk in terms of the long-term risk. You come up with innovative product, and there is a market advantage for that. Digital manufacturing integration, that's where I would like your input in terms of AI, IoT, digital twins, how we can make use of those when we go towards this climate smart manufacturing. And then stakeholder and customer expectation is also there now because we all want to have a better planet for our future generation. So we keep this Mother Earth as clean as possible, as livable as possible for our future generation. That's where it's very, very critical, especially when we're talking about that. So how we can do this stuff, we can have proper material selection and sourcing, looking at sustainability criteria, supply chain assessment, process optimization, product design, and of course waste minimization and circular economy. There are already not from some of the work that I have done and worked with some of these different companies where there are examples. I'll not go into detail, but there are examples out there from say different companies in petrochemicals, cosmetics, automotive companies as well, and adhesive materials where people are working on try to make this life cycle thinking as part of the business case as well. So benefits, just to summarize, like environmental benefit, economic benefit, there is also our innovation and product development. Then we have risk compliance, and social and stakeholder benefits are there, which I already kind of talked about earlier. So in terms of challenges, data, that's what I would like to see when we talk about AI, ML, IoT, digital twins. We need good quality data. Complexity of supply chain, cost and time constraint. These things requires money, expertise, and time. And always there is a trade-off dilemma in terms of improvement in one stage may cause unintended negative impact in another. So those are the things I would like you to kind of focus on as we get into our discussion now in terms of this particular topic. So without further delay, in this particular breakout session, our goal here is to look at how we can integrate digital technologies in terms of low carbon manufacturing as well as critical minerals processing, and how the Australia and Indian case studies on decarbonization industrial systems, and also looking at enabling visibility, traceability, and life cycle emissions tracking across supply chain. So with that, like a broader kind of framework, I invite all of you to kind of raise your hand and share your thoughts so that we can have the discussion going on. So please. So thank you everyone for your active participation, and again we will go forward with the next session now.
Thank you, Professor Dubey, for conducting the session very, very smoothly and for bringing out great insights, which I'm sure all of us will go dig further deep into. I certainly am very curious, and I certainly am very curious to learn about what is happening in other parts of the world in some of these areas. I'll now quickly hand this back to Professor Yellishetty to conduct the third and final breakout session.
Thanks, Rajat. Now we have the last and final breakout session, which is led by my dear friend and long-term colleague, Professor Professor Sapna Narula, who was founding dean at the very prestigious business school, Nalanda Business School at Nalanda University, prestigious Nalanda University. And Sapna and Professor Narula and I go quite long, almost a decade now, and she is also part of our Australia-India Critical Minerals Research Hub. And she has done fantastic research in the mining and social space at Terry. So without further ado, so probably I'll hand it over to Professor Narula to kind of run the session.
Thank you, Professor Yellishetty. Thank you for inviting me here, Dr. Rajat Verma, the co-lead of the session. And thank you to Australia-India Institute for having invited me here. Since this is the last session, I would like to, twist the conversation a bit. And I'm sure Mohan has kept me here because of that angle, and I begin. The purpose of this particular session is that we want to see how policy is aligned for clean tech manufacturing and critical minerals across both the countries. And we would like to see how industry, academia, government collaboration in the net zero transition and CM's critical minerals processing, and how a joint roadmap for both Australia and India's net zero strategy could be in place. And on the translate pillar of the framework, this group would like to explore the tangible outcomes that we have out of these research partnerships in energy transition and climate change resilience. Who are our key stakeholders and how are they benefited? And what existing models or practices have delivered real world impact? So based on the discussions that we have earlier in the morning, it's very clear that both India and Australia have ambitious targets as far as net zero transition is concerned. As part of our net zero strategy, India has set a target of 500 gigawatt of installed capacity from renewables. We are also targeting installing rooftop solar on 10 million Indian homes and producing 5 million metric tons of green hydrogen by 2030. And Indian government is very keen to set up, build hydrogen capacity here. And besides this, our net zero strategy includes energy efficiency and conservation, and reforestation and sustainable agriculture. On the other hand, Australia has similar interests. My Australian counterparts are already aware that how Australia is transitioning to clean energy exports, carbon capture and storage, and this remains India's interest as well. If we talk about green hydrogen, if Australia is targeting 15 million metric tons of green hydrogen, we have a target of 5 million metric ton. And then both the sides are also looking for electrification of transport and sustainable land use. Sustainable land use, reforestation, climate resilience remains important part of net zero strategies of both the countries. So both India and Australia are also creating a lot of green jobs while we go towards transition. At the same time, we also want to see that we are not harming the local communities. So that means here we talk about climate justice and just transition. So let me also compare both sides, policies, how they have been so ahead in making policies during the last decade. So Australia has already, National Reconstruction Fund and Futures Made in Australia and Industry Growth Plan, which is a $400 million program, critical minerals production tax incentive, and hydrogen production tax incentive, battery breakthrough initiative, which is also part of India's plan. And then in Australia, we have, we are targeting advanced manufacturing growth center for SMEs, advanced manufacturing roadmap. On the Indian side, we have production linked incentives. We have already, my colleagues have already talked about National Critical Minerals Mission. The director of NCMM is here, and Dr. Anshu Pandey explained it. We have National Minerals Policy, sand mining guidelines, and we also have India Green Mining Initiative, which is a very important initiative. And Mines and Minerals Amendment Act has been introduced, plus Kabil and other mineral security partnerships we have. So on the policy front also, a lot of points are aligning between India and Australia, and the aims seem to be similar, and in accordance with the Paris goal. So here, we've talked about that how India and Australia have joined hands. There are a lot of initiatives, Indo-Australia Critical Mineral Research Hub, which we are part of, and then there is Indo-Australia Solar Task Force also, which is trying to develop capacities in the solar area. We have an agreement in green hydrogen as well, and critical minerals and green steel. So, as a professor of sustainability and circular economy, we have been looking at these issues, and I have been associated with some of these Indo-Australia initiatives as well. What we feel that here we have a few important areas of our research partnership, and I go back to what Dr. Rangan said about how we can go about for the maximizing the impact of our research, and how do we commercialize. These are the questions that appear from the discussion that we have been having. So efficient mineral extraction and processing, recycling, as Brajesh told already, and recycling and circular economy initiatives are an important initiative, because this is very time saving as well and money saving as well. Responsible mining practices, joint sustainable rating system that we can work on. Battery manufacturing is from both the sides, and this is where we can develop capacities, and encouraging SMEs to undertake joint collaboration. Here I would like to highlight 3 areas in this group we must discuss. One is small and medium enterprises. Since Australia has a lot of schemes for small and medium enterprises, and they should not be left behind, and this is where a lot of youth energy can be harnessed as far as net zero transitions are concerned. So rather than going for various jobs in minerals or mining companies, we can provide capital to them, and this is what China has done. So this is how I would like you to suggest strategies on SMEs as well. And then ESG and investment and data sharing is very important. So when it comes to sharing research data, I think this is where the big gap lies, and through bilateral research we can do a lot on this. There must be some electronic platforms through which we share this data, and although our missions are too ambitious, but there are a few research gaps, and the purpose of this particular group is to explore these strategies, how we can take a joint roadmap for net zero transition. So maybe I have split the guiding question into various smaller questions for your benefit, and how can the policies be aligned to take collaborative advantage between India and Australia, and how various stakeholders can join hands. This is where we need your inputs. Earlier in the morning, Dr. Lisa Singh and Dr. Rangan gave us a framework, and what, according to you, be the effective strategies to bring industry academia together for a meaningful impact. It goes just beyond signing the MOUs. So, I'm talking about, from where the MOUs get executed and how can academic research be transferred to industry. And another important aspect that I'm supposed to talk to in this group is about the community engagement. So how industry, government, university can take the communities, can engage with the communities and look into the social and human angle. I think earlier, in the previous group, somebody was talking about human angle. So I would like you to, give your inputs on the human angle. And then, yes, finance is an important pillar. What are the financial opportunities available? And what other opportunities can be explored? Here, I would like to mention that how India has gone ahead with, various green bonds. RBI has come up with green bond guidelines, and, we are opening these initiatives in India. And voluntary carbon markets is also something that is being developed. GHG emission intensity rules have come up in April 2025. So, what are the various financial opportunities? And the last one is the capacity. So, Mohan already highlighted that capacity building is something that we need to explore further, how we can build the capacities not only amongst the researchers but also at the school level and going to the college level, because it's the school level person who goes to IIT, and it's the IIT person who goes to Monash. Brajesh, I'm right. Brajesh should agree with me. So, how we start inculcating innovation practices and build our capacities for the next 30 to 40 years. So, I have already sent the questions and I invite your inputs. So thank you everyone for giving your inputs on this. And what appears is, I'll just submit in short that we are giving an important, we are considering an important aspect such as, people. You have all spoken about the communities. We have talked about the finance and the technology part of it. So as of now, I think time is short, and I would like to wrap it up. Thank you, Australia India Institute, for inviting me, and thank you, Mohan and Rajat, for taking the lead.
Thank you, Sapna. I appreciate stepping in to help the cause. So that brings all our kind of breakout sessions are done. So we are at the fag end of our workshop. So I'll hand it over to my colleague, Rajat Verma, to reflect on what happened and way forward. Over to you, Rajat. Thank you.
Thank you, Mohan. First of all, a big thanks to all the participants and all the distinguished experts who gave us their views on this very important topic of advanced manufacturing technologies. I think, and of course, I also would want to especially call out Brianna for all the support she's extended us in conducting this workshop. So much appreciation to her. And of course, thanks a lot to Professor Yellishetty. We've been now discussing a lot of things in the critical mineral space for the last year or so. And I do hope that we can collaborate even further in bringing some of these things to the market. I think some themes which clearly emerged out today were around materials being a very integral part of advanced manufacturing, circularity around those materials, manufacturing or a production economy where sustainability and responsibility are important themes that we keep at the back of our mind. I think these were some really important concepts, but I think what also emerged, and I think it was probably a recurring theme across the entire 2.5 hours, and particularly towards the end, captured by Dr. Narula, when she said, can we go beyond MOUs? Can we actually do something? It's high time we are not just finishing this discussion with yet another set of white papers and MOUs and whatnot. And I remember when originally Professor Yellishetty and I had started discussing how do we define success, for me it was a single criteria. Can a real commercial viable project actually emerge out of this discussion, right? Which is addressing some of the themes that we've talked about. So that brings us to the question, why are industry and academia so segregated? I mean, industry, academia collaboration is not something that we are hearing for the first time here. It is an oft highlighted theme in practically every major institution out there, every major R&D department out there, every major government discussions out there. We keep talking about it. How do we actually get industry to become more excited? We as a company, are representing the industry, and obviously I would want more and more of my industry brotherhood and sisterhood to come and participate in collaborations with academia. But I think at the forefront, I have probably identified 4 ways in which this could happen better. First is, of course, policy support, right? The government has to recognize that if industry engages in research, then government has to provision that support because country after country, that first risk taker will not be industry, has typically been the government, and government has typically underwritten that earliest market risk or earliest technology risk that may emerge out of in any particular sector that we're talking about. So that support to local industry in various forms is certainly needed from a domestic policy framework. Then, from an industry's perspective, we need to see a path to commercialization. One of my colleagues had referred to databases reflecting the TRL levels. We have to get those things out. We have to ensure that academia, when it's doing its research, thinks about things. And I think there was reference to multidisciplinary approach. And I think one of those multidisciplinary approach requires both business community and the research community to come together to explain to each other what are they both trying to seek out of this. Shaunak Ray referred to the Antler VC fund in Singapore, which probably provides support to research getting commercialized from day one. Sarb Giddy referred to the industry PhD program in Australia. And of course, the CRC program in Australia has been highlighted as a successful implementation multiple times as to what can be done to actually make sure industry and academia are actually working on problems that have commercial viability. Mohan referred to centers of excellence, creating centers of excellence between academia and industry, aided by the government, and ensuring very clear articulation of IP rights and the commercial participants' ability to exploit the IP till they get the return on capital. Those are super critical to ensure these collaborations are mainstream. And finally, I think the last theme which was talked about, and where I go into the broader reason why all of us are here together, is around the two nations and what they both bring to the table. I think we heard multiple times about how Australia brings resources and how Australia brings a lot of know-how and expertise in deep tech R&D, how India brings market, how India brings a very aspirational population, and how India brings an ability to scale with speed a lot of these tech. And I think these are two very natural and very complementary partners. And we have to ensure that these complementary partners now actually take the relationship to another level and engaging at a policy level where when we are talking about manufacturing and critical mineral policies, where we actually bring both the nations into each other's policy thinking as well, will be super critical for industry to also commercialize what can come out of various research areas. So once again, thank you all of you for your attention. And it was a great workshop. I learned a lot, and I hope to continue these discussions with a lot of you post this workshop as well. Thank you very much.
Excellent. So when you work with an extraordinary person like Rajat, you don't have to do anything. So right. In fact, I've been blessed to work with two extraordinary people rather. One is, as Rajat acknowledged, Brianna Barrett, who had been, a steadfast kind of mentor and supporter throughout this entire process. And of course, not to mention, Rajat is a stellar proven, entrepreneur and also a great academic himself. So I don't have to do anything, but I want to say three things. AI is it resonates with all of us in the world that we live in, right? To me, the AI, how I define is Australia, India, the partnership in the artificial intelligence world, AI world again. For aspirational India, the third AI stands for aspirational India because India. When I come here, I'm currently sitting in IIT, where I'm also a visiting professor at two other IITs, IIT Dharwad and IIT Bombay. Now currently I'm at Hyderabad IIT. So the level of enthusiasm in the young cohort at IIT is unmatchable. It's like they don't want to work in any company, but they want to start their company. So I think that's where I'm coming to give that credit to aspirational India. So there's so much that can be done, and thank you everyone once again for your active participation. Your views have been heard. I think that will help us frame a good white paper, of course, which will be implemented. Not that it's going to be a white paper for white paper's sake. And the very fact that this particular forum is led by an academic and a proven entrepreneur. In fact, this was highlighted both during our interview time and also in today's forum. Quite a few people have said that that's how it has to work, and I'm seeing I have a huge hope that many things that are discussed will be kind of taken forward to implementation. So I think that's where we will end.